Well, we're doing today polynomial factoring day 1. So we've done some factoring before, and they've all been polynomials that we factored before. We're going to take some of those same skills and do a couple different types of polynomial factoring for today. So we're going to start with factoring completely by first pulling out the GCF. Well, GCF we know stands for greatest common factor. So we need to find the greatest common factor between these two terms. So we're going to start with 3x cubed minus 48x. So I'm going to start by looking at my numbers. Do 3 and 48 have a greatest common factor? And they do. 3 is a factor of both 3 and 48. Okay. And then I look at my x's, and x cubed and x. So do they have a common factor? And they do. They both have x as a factor. So once we pull out the GCF, then we can rewrite what would be the remaining binomial after we were to divide out 3x. So 3x cubed divided by 3x, that's just x squared. Okay, and negative 48x divided by 3x, that's going to be a negative, well, here I have 10 and then 6, so 16. So now I have 3x times x squared minus 16. Well, once I pull out a GCF, I have to then check to see if my remaining factor can be factored further. So I want to look at x squared minus 16. It's a binomial. So that I'm going to actually check to see, is it a difference of squares? Because I know that there's some binomials that can be factored that are different to squares. So the front would have to be a square, which it is. The middle would have to be the subtraction. That's true. And the end would have to be a perfect square. Well, 16, yes, 16 is a perfect square. So this is a difference of squares, which means I can factor that further. So I'm going to keep my 3x in the front. And I'm going to factor this. Now remember, for difference of squares, when you factor it, it becomes square root of the front, square root of the back, and then you have a plus 1 and a minus 1. Or if you think about it as a squared minus b squared, you have a plus b times a minus b. Now I can check both of these. Well, there's no squared here, there's no squared here. These are perfect squares, but this is the only difference. So I don't have anything else I can factor. This is not a difference of squares because the x squared is not squared. So here I am finished. I have fully factored 3x cubed minus 48x. Okay, let's take a look at one more on this page, number 5. Again, I'm going to factor out a GCF first, so let's take a look at all of the numbers in my terms. Now I have 3 terms. I have a trinomial. So here I have 2, 4, and 2. Well, all of those have a factor of 2, so I'm going to pull out a 2. And then this one has an x squared, this one has an x, but this one does not have an x. So I cannot pull out any variable GCF. So my GCF for these terms is 2. So I'm going to rewrite this as x squared plus 2x plus 1. Now that I have my two factors, 2 and x squared plus 2x plus 1, I'm going to check x squared plus 2x plus 1 to see if I can factor that. Now this is a trinomial, so I'm going to double check to see, okay, I have a trinomial. Do I have two numbers that multiply to c and add to b? Well, c is 1, so if I think about multiplying to c, I need to multiply to give me 1, but I need it to add to give me 2. Well, the only factors of 1 are 1 in itself or negative 1 and 1, but just 1 in itself would add to 2. So I know that I have the right number. So this is a factorable trinomial. I'm going to rewrite this as 2 binomials. I'll have x plus 1 times x plus 1. I can check each of these binomials to see if they're factorable. They're not. There's not a difference of squares there, so I'm finished. Okay, if you turn the page over, you have the joke sheet. And it asks you to factor the following expressions. Here we're using factoring by grouping. So I'm going to write that down here, grouping. And factoring by grouping is nothing more than finding GCF. So if we take a look at we're going to group these. I'm going to kind of put a parentheses around the first. Oops, I got to fix that. So I'm going to put parentheses on the first two terms and the last two terms. And then I need to look for a GCF in these first two terms, x cubed minus 2x squared. So here I have, I have a 1 and a 2, so there's no common numerical, or my constant, my coefficient. There's no common coefficient as far as GCF, but my x's have a GCF. So I have x squared as a GCF, and if I pull that out, I'm left with x minus 2. Over here, I'm going to put the plus sign, and then I'm going to factor out something here. Well, I have 3 and negative 6, my numbers, and I can factor out a positive 3 out of that one. And I'm left with x minus 2. Now, when we're factoring by grouping, we have to make sure that these things that are in the parentheses, the binomials, are exactly the same. So here I have to have x minus 2 and x minus 2. If they're not, then we need to go back and look at our GCF. Maybe there's something we could pull out differently. Like, for example, maybe we could pull out a negative versus a positive number. But here we have two things that are the same, x minus 2, so we can move on on our factoring by grouping. So what I'm going to do is I'm going to write what I have in common first. That's one factor. X minus 2 is one factor of this polynomial. My other factor is what is in front here, because what we're really undoing is like undoing a distribution. Okay, so my other factor is x squared plus 3. And if you think about going backwards, this is really like multiplying backwards, right? We're undoing multiplication. You could see that they multiplied x squared in, and then they multiplied 3 in. So we're really undoing that by creating these two binomial factors. Then we take a look at both of these factors and say, okay, can I factor them any further? X minus 2, x squared plus 3. Nope, I am finished. Neither of them are difference of squares, so I am done. As always, if you have any questions, see me or Mr. Daniels, and have a fabulous day.